Never before has a man-made object come so close to the sun. The Parker Solar Probe will provide unique measurement data about our star. But for all the excitement about this project, people are moved by one question. Why doesn't the probe melt when it's near the sun? The Parker Solar Probe periodically stays in the hottest layer of the sun, and that is by no means the surface of the sun. It is hottest around the sun in what is called the corona. In this video, you'll learn how the solar probe is braving the heat and what new insights it will deliver. Before we start, we would like to ask you to make an important contribution to our channel and leave us a comment at the end that fits the topic. The journey to the sun, exploring our star, is of utmost importance to us Earthlings. Without the sun, there is no life on our planet. Our climate and seasons depend on solar radiation. The activities of the sun also constantly influence the magnetic field of our planet, and some people even claim that solar storms have similar confusing influences on the human psyche as the full moon. From a purely scientific perspective, astronomers and cosmologists would especially like to learn more about the hitherto mysterious processes on the surface of the sun and the corona. Corona means wreath. This thin glimmer around our sun can only be seen from Earth with special filters or during a solar eclipse. The corona is a great mystery for scientists even today. After all, temperatures of up to 1 million degrees Celsius prevail in this layer, which is located several kilometers above the surface, while the temperatures on the surface of the sun are only about 6,000 degrees Celsius. The sun, like its corona, is not equally hot everywhere. On the surface of our star, constant mergers take place. Things bubble up and forces swirl around. It is similar in the corona, only there the heat is in the form of the finest particle clouds. These clouds or evaporations are directly influenced by the activities on the surface of the sun. The particles which form the corona are created by the fiery processes on the sun, or at least are influenced by them. These interactions are not yet known exactly, and it is one of the tasks of the Parker Solar Probe to find out more about these connections. Behind the effect of the extreme heat formation in the environment of the sun must be physical forces and probably also chemical processes, which we do not know of so far. Perhaps we could even benefit from the probe's findings with regard to our own energy industry. Just think that the electricity you draw from a wall socket always comes about through the generation of heat. If we were also able to generate temperatures or heat using the same trick that the sun uses, we might be able to generate larger amounts of energy much more easily or multiply energy in a simple way and possibly in a more ecological way. In addition to studying the enormous heat generated in the corona, the probe is, of course, also measuring the famous solar storms. These are gigantic particle eruptions. The winds originate in violent eruptions on the surface. During these eruptions, plasma and particle streams are released, which initially waft around in the immediate vicinity of the sun. Eventually, the charges also enter the corona and are released from the sun's gravitational pull by a mechanism that is also still largely unknown. Then these particle streams drift away from the sun at extreme speeds and out into space. If these particle streams meet the magnetic field of the Earth, it is extremely shifted and stretched. Experts assume that such solar winds can override the complete earthly electricity if they reach a certain strength. Solar flares and winds have been intensively researched for not quite 100 years. This was enough to find certain rhythms in the eruptions and the winds. The sun is usually subject to an 11-year rhythm. Within this time, the eruptions occur in certain patterns. The winds were almost predictable for a certain time. Then, suddenly, the behavior of the sun changed. At first, the activity weakened in an unusual way, and scientists were already worried. But then, Suddenly, the solar activity increased again. These events happened completely outside the cycles known so far. On Earth, we cannot be sure that the sun shows extreme whims in its behavior from time to time. Since this could be dangerous for our increasingly technical world, it is of utmost importance that we learn more about the sun. A total loss of electricity would plunge the planet into indescribable chaos within hours. The Parker Solar Probe has an enormously important scientific mission in many ways. The Parker Solar Probe was launched in August 2018. This solar probe is a joint project between NASA, ESA, and several other nations. To launch the probe, NASA took advantage of a window of time when the Sun and Earth were particularly close, and the probe's trajectory was ideal. Since probes cannot head straight for their destinations, but rather move along the gravitational fields of planets, and ultimately also use their force for onward flight, the Parker Solar Probe first made 7 laps around Venus before it could set course for the Sun. Of course, NASA also used these flybys of Venus. In April 2021, the Parker Solar Probe achieved a groundbreaking milestone by flying through the glowing hot corona of the Sun for the first time. During its flight, the probe came within 6.1 million kilometers of the Sun's surface. Despite the extreme temperatures reaching up to 2,500 degrees Celsius outside, the sensitive measuring instruments inside the probe remained at just over 30 degrees Celsius. This remarkable feat was made possible thanks to the efforts of international teams of scientists, engineers, and technicians who spent nearly a decade designing this masterpiece. The key to the probe's success lies in its sophisticated thermal protection system, which includes special materials, a heat shield, and a water-powered cooling system. The Hopkins Applied Physics Lab in Maryland, USA, developed the water cooling system. The thermal protection system is composed of 2 layers of carbon fiber reinforced carbon, which retains its structural properties even at the highest heat, with a carbon foam layer in between. This foam contains large air pockets that significantly limit heat transfer. The outer surface of the probe is coated in white aluminum oxide, which reflects light optimally, minimizing heat absorption. Beneath this layer is a tungsten layer, an extremely dense and heat-resistant metal that boils at 5,900 degrees Celsius, ensuring the heat stays outside the probe. The position and trajectory of the probe are programmed to keep the shield oriented toward the Sun, allowing cameras and sensors to peek just beyond the protective shields to gather data. The Parker Solar Probe's flights through the Sun's outer corona are carefully designed to minimize heat exposure. The outer layers of the corona contain relatively few hot particles, keeping heat transfer tolerable. The probe's fly-through times are short, likened to reaching into a hot oven without touching heated surfaces. On its first pass on April 28, 2021, the Parker probe withstood temperatures near 3,000 degrees Celsius and performed flawlessly, taking measurements, filming particle streams, and departing after just a few hours. When far from the Sun, the probe periodically approaches Venus and Mercury, using Venus's gravitational forces to accelerate toward the Sun. The next close approach to the Sun is expected in 2024, with the probe anticipated to come closest on December 24, 2024. 5 total approaches are planned, with the final one occurring in July 2025. While the probe is not expected to remain functional beyond summer 2025, its mission could be extended if it survives. The data collected is expected to revolutionize our understanding of the Sun, revealing details about solar winds, radiation cycles, and the processes occurring on its surface. Named after U.S. scientist Eugene Parker, who coined the term solar wind, the Parker Solar Probe is a testament to humanity's ingenuity and commitment to space exploration. At Simply Space, We will continue to share updates on this extraordinary mission and the insights it provides about our sun. Let us know your thoughts on the Parker probe's design and achievements. Do you find its technology fascinating, or do you take such advancements for granted? We welcome your input and opinions on solar exploration. If you're subscribed to our channel, don't forget to mention it in your comment and be sure to like the video. Thank you for joining us today, and we'll see you next time.